Hey Stat Class, I'm making this video 2 weeks before this date, so I'm not sure if I'm going to aim it at the right spot for where your studies are. I'm aiming for you to watch this on Monday of the 13th of November, but I'm not sure if I'm going to hit it right. I might have to adjust these videos so this might not fall on the correct date. We're going to look today at scope in that how deep, how wide, how tall can we make our conclusions from our studies, our experiments. And it harkens back to the first day of class where we learned the whole goal of statistics. Do you recall what that word was? Let's see. Remember that? The E doesn't show up really good here. Okay. I'm sure you do remember it, so I won't waste your time. Inference. So, basically, in our scenario, inference means what can we infer? What can we conclude from our experiments and surveys? So I'm looking for a cause and effect relationship, which heretofore I did not allow you to make. We made a big deal when we were first experiencing X and Y values, variables that had a strong association, that you could not conclude causation from that. And that still remains true, but now we've added some additional power to our experiments where we can say this variable causes this effect. So it all depends on the design of the study. So let's take an example. Suppose there were 21 volunteers. And this is day 9 notes, I believe it is. So you're writing all this on day 9 notes. Let's look at the design of a study. Say there's 21 volunteers, and they were brought into a room where they were randomly assigned to 2 groups. One was sleep deprived for sleep. Let's see if I can spell that word. Sleep deprived, no sleep for 1 night. Miserable. And then the other one, the other group is I can't spell, unrestricted. Alright, so you got the point there. 21 volunteers set up randomly between 2 groups. One gets no sleep for a night and one gets unrestricted sleep. Then 2 days later they come together and they have a test, some sort of performance test, and lo and behold, the sleep deprived had a lower performance. Alright, so I guess that's no surprise. But I just want to show you the design of the study. And the question is, what conclusion can be made, or conclusions? And I have 2 main questions. Can we say that sleep deprivation causes decreased performance? Can we say that? And the answer is yes, we can say that. So I will teach you today how you know whether you can or not. And it's all in the design of the study. All right, and then the second question is important. Can we generalize that conclusion to the entire population? And the answer is no, 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 no. All right, so let me give you a little bit of guidance on how we can decide that. The reason this answer was yes was this very important word that fell right here. In the middle of the experiment, were the treatment groups assigned randomly? So if they were, and in this case the treatment being sleep or no sleep, was it assigned randomly? Were those groups made randomly? And the answer was yes. When that happens, we can assume cause and effect. So let me make a statement of that. Randomly assigning subjects to treatments allows for cause and effect statements or conclusions. All right, so that is why this was so powerful that I even circled it. However, what was there about this study that does not allow us to generalize to the entire population? What do I mean by that? Well, I'm not sure what the population was in this study. Let's say it was 21 college students. So can I generalize? I was able to say that sleep deprivation causes decreased performance, but can I say that we saw that with the 21 people in the study, but can we say it to all college students? And the way this experiment was designed, we cannot. And the reason was right here. They were volunteers. The power of randomness was not employed in the study when they originally chose the participants. So therefore, we can say that this generalization that sleep deprivation causes lower performance for the entire population of college students, that generalization cannot be made. All we can say is for those 21 volunteers, sleep deprivation caused lower performance. All right, so let me write that out in a statement. Randomly assigning, randomly, I'll say choosing. Subjects for a study allows for generalization to the larger population. All right. Randomly choosing subjects for a study allows for generalization to the larger population. All right, so let's see what's next. Let's go ahead and make a chart out of this idea and sort of get everything together. So here's the chart, and on one side of the chart I'm going to ask this important question. Were the individuals for the study randomly selected? Alright, and we'll say in each one of these blocks we want to know, can we assume causation? So I'll call that cause and effect. And we want to know if we can generalize. So we're going to want to know that in each of these blocks. So let me set this up. I think yours is already set up on that day notes. Maybe not. It's hard to remember back a whole year for me. Alright, so I put those in all 4 blocks. And were the individuals for the study randomly selected? And the question is, if the answer is yes, I'll put yes on this row and no on that row. If they were, and then the other question is, were the individuals randomly selected for treatment groups? And up here we'll put yes and no. So here this chart will represent all 4 combinations that are possible. So in the first block I'm saying the individuals, this has a yes and a yes, so the individuals for the study were randomly selected, and once they were randomly selected for the study they were randomly selected for treatment groups. So when they're both yes, we can assume cause and effect, and we can generalize. So that's the strongest case. But what happens when the individuals for the study were randomly selected and were not randomly selected? I'm sorry, I'm on this block. But they were, the answer is yes, they were randomly selected for treatment. So that was just like the sleep study we just saw. So we could say cause and effect for that one, but we could not generalize. We could only say it was a cause and effect for those 21 volunteers. So that will always work in this way. All right, what if the individuals for the study were randomly selected, but once they were in the study, the treatments were not randomly assigned? So you can probably see that the cause and effect is going to be no, but we can generalize. That's a weird block. So I'll give you an example of that coming straight up. Right now, just get the gist of the yes and the no scenarios. And so here in this last block, no, they were not randomly selected or randomly assigned to treatment, so it probably doesn't surprise you that neither of these can be made. Can't assume cause and effect, we can't generalize to a larger population. Alright, so that kind of puts everything together. And so let me go ahead and show you an example. So you are welcome to stop the video whenever you need to. Get a piece of paper here, cover up this so it's a little bit at a time. So again, we're looking at inference rules, and we're looking at a scenario where we can apply what we just learned. Alright, So the first scenario, design number 1, we'll call it, all dental patients with appointments in the next 2 weeks were going to take part in a study. So here's the design of the study. They're going to be given a survey, and if they do take vitamin C, then that will be noted. And if they do not take vitamin C, that will be noted. And then at the end of the 2 weeks, they'll look at all the data and compare the number of canker sores between those who took the vitamin C and those who did not. All right, so the 2 questions come out, and the first one was, were these patients randomly chosen for this study? And the answer was no. It was a convenience example where whoever happened to make appointments in the next 2 weeks, whoever walked in the door in the next 2 weeks. To randomize the study, the doctor would have to give every one of his patients a number and randomly select a number and ask them to come in for the study. So this is a no for random selection for the study. Now once they came in the door, ignoring that fact, all the people that came in for 2 weeks, were they randomly assigned to take vitamin C or not take vitamin C? And the answer to that is no, because they were just surveyed, do you take vitamin C? And there was a yes group and those that said no. So this was not an experiment at all. No conclusion can be made relating vitamin C to canker scores, and of course, no conclusion for generalization to a larger population. All right, so that was design number 1. Hopefully you saw that coming. Let's do the second scenario. All dental patients in the next 2 weeks come in, all the dental patients in the next 2 weeks that come in are going to be randomly assigned between 2 groups. And one group is asked to take vitamin C for 3 months. And the other one is to take no vitamin C for 3 months. And at the end of the 3 months, they're going to compare the number of canker sores. Lovely, lovely. All right, so in this scenario, we notice, where's our little chart? Oh, I just noticed that chart was on day 8. I think I mentioned day 9. All right, over here on the chart, were the patients randomly selected for the study? Over here, this question. Which one? They were not. Once again, it was those who came in the first 2 weeks, or the next 2 weeks. So they were not randomly selected. So therefore, we're not going to be able to generalize the results of this study to any larger population. All right, so then, were the individuals randomly selected for treatment? Yes. They were randomly assigned to take C or not to take C. So therefore, we had a yes for this question and a no for this one. So that brought us to this group, which I pointed to a little too early. That we can assume cause and effect, but we can't generalize. So in this specific case, we can say that vitamin C causes fewer canker sores. In these dental patients, notice I cannot generalize to all dental patients. So I can only say in these dental patients that took part in that study. Not a very powerful statement, but more powerful than the one with design number 1. All right, number 3. Suppose we randomly select dental patients from the town, and so therefore we somehow do a random selection. We've learned ways to do that. So we randomly select dental patients from the town. They come in and they take a survey. Do you take vitamin C and do you not take vitamin C? At the end of a certain amount of time, they compare how many canker sores the C group had with those who did not take vitamin C. So, what kind of conclusions can be made for this one? Alright, so here we are again. Were these individuals for the study randomly selected? Yes. Were they individuals then randomly selected for treatment groups? They were not. So we had a yes and a no. So therefore, we cannot say cause and effect, but we can generalize. And I said that's the weirdest block. So let me go over what that means. That means the dental patients in this town have fewer canker sores when taking vitamin C. So what kind of conclusion is that? Do you see that I'm not saying that vitamin C caused fewer canker sores. I'm just saying that we observed fewer canker sores. So we're not saying cause and effect in that statement. But we are generalizing to all the dental patients in the town. So, because those are the ones that were, the sample group came from the towns, the dental patients in the town. So the dental patients in this town, that was a generalization, because remember we had a sample group going through this. So we're going to generalize to all the dental patients in the town, but all we can say is that they have fewer sores when taking vitamin C. We cannot say that there is a cause and effect relationship. So that's the toughest one, I think. All right, number 4. You probably know what's going to happen here. We're randomly going to select dental patients in town, and then we're going to randomly assign vitamin C treatment, yes or no. So that's going to be a yes, yes, and it'll bring us to that block where we can make these conclusions. Vitamin C reduces the number of sores for dental patients in the town. So it does cause it. All right. So on your assignment, you're going to be seeing 4 different problems like that in your homework. And you're going to do this kind of analysis using the ideas from the chart in order to make your conclusions. What you can infer and what you cannot. So those will be on page, grab my book here. They are on page 269, and they are numbers 102, 103, 104, and 105. Alright, so I want you to take those 4 and see whether you can generalize to a larger population and if you can say one variable causes the other. Alright, the reading for that is on pages 261 and it goes through a little bit about ethics to 267. I want you to read that about ethics, and it is not included on the AP test. Ethics is not. However, I want you to read it. And I'm not sure if it's on our tests or not. I can't recall. But I know it's not on the AP test. But I want especially anyone who might take a future statistics course or actually practice statistics in the workplace needs to know about the ethics. Alright, that's it for this video. And if the class is not over, which I'm assuming it isn't, you can go ahead and do that assignment All right, carry on.